So now what we're going to do is we're going to start getting to the point of, let's get some of this information out. Let's start communicating with the outside world. So we're going to start this with just discrete and serial first. Okay, our next section is going to be network communications. So right now we're just going to concentrate on the discrete and serial ones. So we're going to talk about the different functions used to write from and read from a discrete port as well as serial port. We're also going to talk about what does it mean to be online, what really happens there. So remember, the amount of discrete IOs you have, whether it be inputs or outputs or whether you even have inputs, as well as serial communication, is going to be dictated by the IO card that you're using. So if you're using an IO card, you're going to get additional ones. If you're not using one, you may not have access to any like discrete inputs or serial. So to get to this discrete, and when we're saying discrete, we're just saying that the line's going to be on or off. Okay, so it's going to be a 24 volt or not, or rather, remember we have the separate commons. So, you can either be driving current or sinking current, whatever works for you, setting it up. So with that said, we can get to each of the individual ones by going to our sensor, discrete I/O settings. And in this case, we're going to talk about input first. So we're going to go to discrete I/O settings input. Now, if we're using a 5000 or a micro and we see this page completely blank, we know it does not see the I/O card yet. If we're using a 7000 and we only see 3 inputs, we know that it's not using the I/O card. It's only pulling the stuff from the camera. So what we're going to need to do is down to where it says that I/O module, we're going to choose that. I'll show you how to go out and choose your I/O module. And then you're going to say, okay, connect it to my I/O module. And now you're going to see that it opens up so that you can see additional inputs in this case. What you're seeing right here is actually a 1400. So this is the one that goes with the 5000. Input 0 is not there. On your micro it is. So that's why they have it blanked out. Now you'll notice that there are lines next to them. Those line numbers are going to match up with the line numbers on your I/O card. You're also going to notice that you have a name next to it. That name there is for you to place something there so that you can document what's going on with your function. So if it's an input, you could say it's the trigger, or you could say it's the PLC selector, or you could say it's the proc switch, whatever works for you. Now this tag is not used anyplace else. So it's not like you're doing this tag and then you're going to reference it inside your program. It's only for documentation purposes so that when you look at it, you know what that line does. Now next to it, you're going to have the type that it is. And so there's going to be a pull-down list of different types you can use. Now if I'm using user data, that means I'm going to do something with that data inside the program. So I'm going to get back to user data in just a moment. Then we have event trigger. An event trigger just basically says, when something comes in on this line, it's going to trigger an event. And we'll talk more about events a little bit later, but it's going to trigger an event, and then I want to deal with that event. The next thing is going to be the job ID number. Now, job ID number works with job load switch. And this is going to allow for you to actually switch programs on the fly via discrete input. Now, the deal that you have to do with this is when you save your program, you need to save your program with a number in front of it. So let's say that I wanted to have 6 programs in memory. So if I have 6 programs in memory, how many lines do I need to use to get the binary form of those? 3, exactly. Because if I use 3 lines, I can get up to 0 through 7. So I can get up to 8 programs there. So that's how job ID number is going to work, is it's going to be a binary input coming in that it's going to convert it to a decimal. Now, how the job ID numbers works is it's going to be sequential of your inputs, all right? So what I mean by that is you can't put 1 at line 2, 1 at line 4, and 1 at line 6. They need to be next to each other. The second thing is whichever's on the lower line is going to be your least significant bit. The one on the upper line is going to be your most significant bit. So when you're reading it out and you're converting it, that's how you can remember it. So now what happens is your PLC is going to put that number on there. So if I have 6, I could have my job saved inside memory as like 0 underscore my job, 1 Yahoo, 2 underscore let's get going, 3 Friday is awesome, whatever you want to call them, but you're putting a number in front of it. So what it's going to do is it's going to resolve that number first, and as soon as it starts getting to the alpha characters, it ignores those. So just that number in the beginning. It's got to be in the beginning, not the end. So what's going to happen is PLC is going to put that information on the job ID number, and then it's going to send out a trigger to the job load switch. And the job load switch is going to see that trigger and say, oh, let me go read what's sitting on the job ID lines, resolve that to a decimal value, and go look in my memory to see if that program is there. If that program is there, I'm going to go offline, load the new program, and then come back online again. If the program's not there, I'm just going to keep running my current program, and I'm just going to send out that I had an error. The job load switch can either be before or after the job ID numbers. That doesn't matter. And you might say, well, how many can I have? You can have as many job ID lines as you have input lines minus one, because one of those lines have to be the job load switch. But all the rest could. So if I have 8 inputs, I could use 7 of them for job ID numbers. So that would be 2 to the 7th. Off the top of my head, that's 128 jobs that you could do. Another one might be just online, offline. So if it's a high input, it'll turn it online. If it's a low, it'll turn it offline. And then that's basically it. Now, anytime you're doing some type of trigger, whether it be the event trigger or whether it be the job load switch, you can also state what's going to cause it to trigger, okay? Because triggers are usually looking at an edge-based as opposed to a level-based. So do you want it on the rising edge or the falling edge? On the event, you can choose both as well. Catch it on the rising, catch it on the falling, whichever one works for you. User data. So remember I said user data means I am going to be doing something with this data. In fact, I'll probably be trying to read it in. So user data is usually going to be used with something called read discrete. So how it works is it's going to ask for an event. What event is going to make me go out there and read this line? By default, it's what? Camera trigger, exactly, the acquisition. The fact that the acquisition happens means that it's going to go out there and it's going to read, do I have anything sitting on that line? Then it's going to ask, well, what's the start bit? So it's going to say, what line should I start reading at? And how many lines should I read? If you're reading multiple than one line, what it's going to do is, even though you have a binary value coming in, it's going to reference it in the spreadsheet as a decimal value. So it'll do the conversion for you. What you're going to get on your spreadsheet is you're going to actually get the function of your read discrete, and then depending on how many number of bits you have, are the auto-inserted LEDs for it, letting you know what are sitting at those lines. So let's say that I want to read data sitting on line 1. So I'm going to want to make sure that I go in there and I set my type to be user data. Then I'm going to go grab a read discrete. I'm going to have it, the event be A0, so with every acquisition it's going to take a look at what's going on in the discrete line. And then I'm going to start at line 1 and only read 1 bit, because that's all I care about, just that 1 bit. So what's going to be sitting in my spreadsheet is if there's nothing there, it's going to give me a 0, it's going to be yellow. And otherwise, if it reads it as a 1, it's going to be red. Now you might say, can I change the color of the LEDs? That's actually an extra credit in your lab, is to change those colors. And the answer is yes, you can. Those are just the default. Now discrete outputs, very similar to discrete inputs. Okay, you're still going to go to your sensor, discrete I/O settings, but this time look at the outputs. If you have already set the I/O module, then you don't have to set it here. You'll see the extra I/Os on the outputs on there. If you haven't set the I/O module yet, then you will only see 2 outputs and 2 LED outputs for both the micro and the 5000. And I believe you'll see 4 outputs and 2 LED outputs for the 7000. So if you're only seeing limited number, you know, uh-oh, oops, I don't have my I/O module selected. And so you need to go make sure you select your I/O module. Once again, it gives you line numbers. Line numbers are going to match up with the numbers sitting on your I/O boards. Then you're going to have your name, once again. This allows for you to document what is this output doing. And then it has the type. Now, if I have programmed, it means I'm going to be probably generating something from this line. So I'm going to talk about that in just a moment, having the programmed one. The next one up there is going to be strobe. Now, strobe is special. Strobe only exists on high-speed output 1. Our ordering of which lines go first varies between the 1400 and the CIO micro, so be careful with that. The 1400 have the high-speed output lines first. The micro has the high-speed output lines next to last. So just be careful, make sure you know which lines are which. The high-speed output lines mean those are the ones coming from the camera itself. That if you're using a micro, you can tie it to the board. If you're using a 7000, you're coming off the cable still. Coming right off because you're coming right out of the camera with it. Now, like I said, strobe is special. Strobe will only exist on high-speed output 1. It's the only output line that'll show you strobe. And what strobe allows for you to do is to control an external lighting module with the camera. Now, how strobe works is you need that light to get at its maximum right at the special time with the camera. It's called the CTI, the charge transfer interval. This happens to be like 2 line scan widths. This tends to be in the order of microseconds. as opposed to nanoseconds. So that's why we need high speed, as opposed to milliseconds. That's why we need high speed output. We need it to react exactly when we expect for it to be sent. So if you have your strobe set up, and this is, you don't have to think about how many times the system takes care of that. So if you have your strobe set up and you're acquiring the camera and you're seeing the strobe fire, you're halfway there. Okay, you're halfway there. Okay, it's seeing it, it's firing when the camera's firing, great. Now what I like to do is I take the camera and I point it on the strobe and I let it run continuous. And what you should see is a constant light. I should not see any variation in the light level there. It should be constant. In fact, if I'm using an LED strobe, I should probably even see every little individual LED, and it just looks like a constant picture there. If that's what's showing, you're perfect. Good to go. But if you're seeing some level changing there, then you are just slightly off with your timing. And you might need to change it from being a rising edge to a falling edge, because you can change that in your details for the strobe. Or some of the strobes come with a leading edge versus trailing edge input. You just switch them. Just switch that there, because you're just slightly off with your timing. Because with a strobe, it needs to be constant every single time. It needs to be that sweet spot. Now, you can also just set outputs to be high or low. That just turns them on or turns them off. You can also say acquisition start or acquisition end. So now, if I have acquisition end, I could have a signal go to my PLC. What might be a benefit of using acquisition end? Processing hasn't started yet, or it will be starting shortly. But right when my acquisitions end, well, how could that be helpful? But we could probably send this back to the PLC, because at this point you can move the part. Okay, you've already acquired. Part doesn't have to stay in front of the camera anymore. So if you need that extra time, like some settling time sometimes if you're doing a high-speed application and your parts need to settle, great. Go ahead and tell the PLC right after I'm done with acquisition, start moving that next part so that the next one's ready, so that as soon as I'm ready to acquire it, let it go. We can also do system busy if you put an oscilloscope on it. Jumps all over the place. You could also do job complete. Job complete will signal give you a signal as soon as an event that causes the spreadsheet to fires the spreadsheet. Everything's done. It does not mean that all the I/O has completed. If you did a write image FTP where you're writing an image out to an FTP server, does not mean that it has completed that sending it over. It just means system's done, has put its outputs out to its threads, and it's ready to do acquisition and processing again. Okay, I/O is still running on its own thread. Job load OK, there's also a job load fail. These both are used with the job ID numbers and job load switch to let you know whether you've loaded it or not. And we also have some error conditions. The one that I like to use is missed acquisition. I like to use that with troubleshooting. Because if all of a sudden, I have a proc switch, my part should always be right in dead center in my view. And all of a sudden, occasionally, I'm getting errors because it's moved over a bit, or it's coming in too soon or something. What's probably happened is that I'm getting some type of signal and being induced on my lines. And so it thinks that it's triggering when it's not. So what will happen is, whether it's coming too soon or after the fact, what I'll end up doing is, if I say missed acquisition, if it's already acquiring, then another signal comes in. It says, oh, sorry, I'm in the middle of acquiring. This is a missed acquisition. So if I start seeing, if I turn that on and I start trying to count those, see how it's coming up, it'll let me know, am I having these spurious, either my proc switch is bouncing all over the place, or I'm having some type of noise being induced on my line. Let me clean it up, because otherwise I'm getting some false triggers. And of course, you can also monitor whether you're online or offline. Note the green LED and red LED. These are just lines in the discrete output. But it will control the LEDs on the cameras. All of the cameras have those, a green LED and a red LED that you can write to. You're doing the details. Depending on which signal you're using, there's going to be a different detail box. The main one is kind of your programmed. And your programmed is going to allow for you to either have a pulsed output, or by default, it's not selected. So it will be high as long as you set it high. It'll be low as soon as you set it low again. So it's a level-based as opposed to just pulsing for you. If you do pulse, you can say how many milliseconds you want it pulsed for. You can also do this acquisition delay. Now notice the acquisition delay says N. That's because this is for like shift registers. Let's say that you have bottles coming by the line. So you're inspecting this bottle, and it will be at its reject mechanisms in 5 acquisitions from now. Boom, it acquires, and it goes 1, 2, 3, 4, because all the other ones are happening. So behind the scenes, Insight creates a shift register. Takes the information about it, boom, 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 so that by the time that it does in acquisitions later, so if you said 5 acquisitions later, it will take whatever that result was, and it'll either kick it off the line or let it go. Now that's great if you have your lines set up so that they're back-to-back. Acquisition is beautiful. Doesn't always work that way. But the other way is if you have a constant line speed. So you know when you acquire the part from when it gets to its kickoff mechanism, you know how long that takes, then you can say time after trigger. Because you know the part will travel that distance in that time. Once again, a shift register will be used and it will be kicked off. Now you need to make sure that this time is greater than your cycle time. If it's not greater than your cycle time, I bet you're not going to get very many things getting discarded. If you're using strobe is here where you can set your rising edge, falling edge versus acquisition start or trigger received. Okay, there's a couple in there. Now, like I said, programmed means I'm going to do something to send it out. So the actual command that I'm going to use is going to be a write discrete. And the write discrete command is going to look very much like the read discrete. It's going to say what event is going to cause me to write. So right now it's going to be acquisition, A0. So with every acquisition, it's going to write the information out. It's going to ask me what bit I want to start at. So what line on my output do I want to start at? And how many do I want to use? Now, the last thing it has, which our read discrete did not have, is what's the value you want to write out? So you need to reference an integer there. Okay, what value do you want to write out to this line? So with every acquisition, it's going to write that value out. Now I'm going to talk a little bit later about dependencies. So you don't have to worry about, hey, is this writing last data out or the current data? Insight is completely governed by dependencies. So it will not write the data until that cell has had a chance to run. If it hasn't had a chance to run, then it'll wait till it runs. Now, if you have it disabled, it had a chance to run, it was chosen as being disabled, and then it will just print that data out for you. So what you'll get inside your spreadsheet is the write discrete. The number is actually where the write discrete command is. And then the LEDs will be your auto-inserted amount of LEDs that you put in for the number of bits. Now, how many people are doing serial port communication? No one? So we do serial too. I'll run by this kind of quickly. Our serial commands are found underneath our sensor serial settings and stuff. And so we would set it up to be the baud rate and setting, whatever the device that you're communicating to. Okay, so you need to make sure you set that up. Then we have this concept of modes. And we have some different modes you can do. Like the text mode is just ASCII. We're going to use read and write serial to send out ASCII or receive ASCII communication. They're very similar to each other. Both of them are asking for what event do you want to actually either read or write. And then they're also going to say what port, which your only choice is one. And then on the write serial, the only extra thing is what's the string you want to write out. Now note I said string. Guess what most of your data is inside your spreadsheet? Floats or integers, or that's what most of it is. So you're going to need to cast it to a string and then send it out. There's a few ways that you can cast to a string. Now the next part is your native mode communication. I talked a little bit about that yesterday when I talked about robots. Remember I said that there's a set of commands that allows for a third-party device to control Insight. So for serial, if I turn to native mode communication, if I send an SO0, it'll set it offline. Otherwise, if I had it at text and I sent in SO0, it would say, oh, SO0. You know, wouldn't do anything special. So by turning it to native, I'm saying I'm going to have a special set of commands coming in on these port. Do what you need to with those commands. And we have a whole list of those commands in our help file underneath communication reference native mode communications. We can turn the system on, open a job, save a job, get information to the spreadsheet, put information in the spreadsheet, tons of stuff we can do. DeviceNet. How we accomplished DeviceNet was through a DeviceNet adapter. So we sent serial to the adapter converted it to the DeviceNet. The only difference with this with serial is instead of using the read and write serial commands, we use the read and write DeviceNet commands. They just put the control characters in the order that they need to be to run on the DeviceNet highway. We used to also support the Motoman and Kuka robots because they required certain control characters. These were for the serial versions of those robots. It allows for us to communicate to them. Otherwise, you could also just shut down the port by saying unused. Just shuts it down. You don't have to worry about it. So now one of the things I've been talking about is event. So we are an event-driven application. What does that mean? Sure, you've probably heard VB and .NET applications tend to be event-driven. What is an event-driven application? Something needs to happen for the program to start, for it to start running a set of commands. So in our application, what's the main event? The acquisition, exactly. The fact that we're getting a trigger into our system and we're causing the acquire. That's the main event. And in most cases, that's taken care of us. But Insight can also be asynchronous as well, which means it can accept events that are not tied to the acquisition, that is coming in at a different time. Now, if it is in the middle of doing a spreadsheet, it will wait until it's done with the spreadsheet before it services any additional events. Otherwise, if it's not in the middle of a spreadsheet and an event comes in, it services it immediately. Now, you can choose when you have an event function, the event function will allow for you to choose what's going to cause the event. So it could be error conditions, it could be what's sitting on a discrete input line, it could be just some soft events. And all the soft events means I'm creating an event in my program somehow. So it's kind of my own software type event that I want to force an event to happen when maybe a certain set of conditions come up. Now, we also need to think about whether we're online or offline. Now, right now, when I go online, what does that mean for me? Well, technically, the program was running before. I mean, I was doing the calibration and everything, changed its real-world units and stuff even when it was offline. You are communicating. You are accepting your inputs. You are accepting network communication. You are triggering via whatever you've set A0 to be. So since we set A0 right now to be continuous, that is why we see the acquisition going as soon as we go online. If you take a completely new application and you go online, guess what? It's not going to be continuously running, okay? Because by default, it's camera trigger. So it's going to be looking for a proc switch. That's what it really means to be online. Now, some of you have already noticed that when you are online, that, well, we haven't really done network communication or any of our communication yet, but you can get to that. But you're not allowed to write anything in the spreadsheet. You're not allowed to open up any of the functions. As soon as you go offline, you can get into the spreadsheet and the functions, but actually we'll notice that we really don't have any communication at that point. Now, we can still do things that you need to be offline for it to be able to do, so it's still listening to those. But anything that requires for you to be online, that's disabled until you go online. Now, there are 4 ways to set the system online and offline. Up until this point, we've been using mode 2. Okay, we've been going up to our little button there and saying online, offline. But we can also go to sensor startup, and we can have it start up with a particular job that's been saved in the memory of the camera, as well as starting online. So that in case you have a power failure, you're not having to run back out to your line, set up all the systems again to get them running. Instead, they're kind of off and going by a default. If you might have a selection of jobs to load, maybe you don't want it to be offline yet. Maybe you want the PLC to dictate what job it's about to load, and then have the PLC pull it online. Whatever works for you. We've also found out that with a discrete input line, we could turn the system online and offline. And we also talked a little bit about native mode communications. Allows for us to turn the system online and offline. So there's different ways we can go online and offline. Now, whenever you're doing I/O, there's a few things you need to keep in mind. First, if you're doing any discrete communication, the value that you reference has to be an integer. If you're doing any serial communication, the value that you reference has to be a string. So you need to keep those in place. You need to be online to send or receive any I/O. And all the settings that I've been talking about are system-wide. What does that mean? That means it's not saved with the job. It is saved on the camera. So if you switch jobs, that does not change your I/O settings. Now you might say, well, that doesn't make sense. Think about it. When you change a job, are you going to run out to your line and start rewiring things? No. So you need to be aware of what your hardware setup is on your line and design your program to it. You might not use all the lines. That's fine. But you need to match it up with it so that you're not changing things around. All these are part of the proc.set file, the processor settings file inside the system. When you do a reset to factory default, this is one of the things that gets pulled. So we talked a little bit about serial communication. We talked how we could send and receive serial using the text mode. And we also talked about some of the other modes, such as native mode communication and some of the robot communication. We also talked a little bit about discrete outputs, and that we're going to get additional ones depending on the expansion module that we use. We can use read discrete to help us read information coming from user data. And we can also use write discrete to bring in or to write out some programmed information. There are 4 ways to go online and offline. If one way says offline, you are offline. Now, you might be in a quasi state. So instead of it going to gray and saying offline, it might say like discrete with a little question mark and be yellow. It's just letting you know, technically I'm offline, but I can't get into the spreadsheet yet. Until you fully pull yourself offline, it won't let you get in the spreadsheet, but it's still saying, I'm waiting for the discrete to turn me back on again. And when I go back on, I'm good to go, but I'm not totally off yet. The event functions allow for you to create custom controls within the spreadsheet. And we've added, way back in like 3 point something, we added the idea of events to our write functions so we can control when something's being written. Whenever that event happens, which by default is usually A0, it means I'm going to write something out with every acquisition. Now, the first thing I'm going to need to do is I'm going to need to attach myself to my I/O module. Now, some of you might have a blinking yellow thing down here saying, I have no idea where I am. Or some of you might not have it there. If you did a reset to factory defaults, that should have killed your I/O module, which is that's fine. So what I want to do is I want to attach to it first. So I'm going to go in and sensor, discrete I/O settings. So where's my discrete I/O settings? Here they are right here. And I'm just going to go to input settings first. And because I did a reset to factory defaults, it put me back to just my default values. So since I see 3 lines here and I'm using a micro, I know that it has not seen my I/O module. It's only seen the inputs that are actually on the system itself. So what I want to do is I want to grab that I/O module. So I'm going to say I/O module. And it's going to say, OK, do you want to do direct? Direct means that it's coming right from the camera itself, no I/O module. No, I want one. So now I have a choice of I can use a CIO micro or a CIO micro with a CC link. OK, well, I'm using the CIO micro. So I'm going to say CIO micro. Now what it's doing is it's going out to my network connection and saying, well, what micros do I have out there? And if I take a look at them, we've actually named them with little animals and everything to make it easier for you guys to find it instead of... So I'm sitting there with my CIO micro. Mine's a rabbit. So I'm going to choose my rabbit. Now notice there's a monkey and a seal here, okay? And when I see a master and an IP address next to it, it means someone has already grabbed those units. They're already attached to them. So what I want to do is I'm going to grab my rabbit. No one's attached to that. Now, it is an EIP device, so there is a request packet interval here. You don't want it so small that it's constantly polling for information, and you don't want it so big that things can skip in between it. So I'm going to leave it at 20. That's fine. If I need to change my settings, I can change it to be DHCP or whatever the IP address. This is where I changed its name. I can change that. I'm fine with this right here. And then if I need to update the firmware, when we go to a new version, very often we might have a new firmware for our CIO micro. It doesn't show anything. I'm going right from 131 build 90 to 131 build 90. That means there's no difference. So I don't need to upgrade any firmware. Beautiful. So I'm going to go ahead and say OK now. And notice that I have all my lines here. In fact, as soon as I say OK, I'll notice at the bottom that it gives me this little green area there that says IO OK. So it has let me know that I have successfully connected to the I/O board. Only one camera can connect to a single I/O board. Okay, so cameras can't share the same I/O board. So let's go back to that again. And what I want to do is I want to set up my input. So I have a little button on my I/O, and I want to set up where basically I want to see what that input button's doing at any given time. So I'm going to go up to Sensor Discrete I/O Settings, pull up input settings, and I'm going to see, well, what line is my button on? So take a look at your I/O board right now, and take a look at where your button is connected to on your I/O board. Input 0, yep, and the other side is connected to power. So every time I push it, it's going to do power. Now notice the I/O common is connected to ground. Okay, if I didn't have the I/O common connected, it wouldn't work. So I have it connected to ground so that when I hit the power, it's going to see a trigger coming on that line. Beautiful. So I'm going to call this button, just so I know what's sitting on line 0. Now the type, I'm actually going to make this to be event trigger. What's the event trigger is going to be is every time I push that button, it's going to cause an event to my system. And so I'm going to want to read that event. If I'm in the middle of running my spreadsheet, it's going to wait for the spreadsheet to finish, and then it's going to reference that event. Otherwise, it's going to reference it immediately. Now, my signal, for this case, I'm going to do both edges, meaning it's going to send an event trigger when I press it down. It's going to send another one when I release it. Now, you might say, whoa, just stay with me on this. There's a reason I'm choosing this. So I'm good with this right here. I'm going to go ahead and say OK. So my I/O is set up for that. Now what I want to do is I actually want to capture that event. Because right now I'm going to be sending an event in, but my spreadsheet doesn't know what to do with it yet. So I'm going to say count button pushes. Say OK, give it a little background. So before I can actually count the button pushes, I need to grab that event. Okay, I need to say, hey, when does that event happen? So the function I'm going to use for that is actually called event. And it's going to be found, if I close up my coordinate transforms, it's going to be found underneath input and output, and it's going to be called event. So I'm going to drag and drop that in. Now the event is asking what trigger, okay? What trigger is going to, am I trying to look for here? Okay, am I looking for an acquisition error? Am I looking for some serial port errors? Am I just doing that a manual event was fired, that it's online or offline, whatever works. Notice that it says discrete, but it doesn't say whether it's input or output. So how do I know which one it is? Well, this is going to be for reading. It's implied that it's an input. If you're writing out, your spreadsheet's controlling that. But if it's coming in, it's implied that's the event you're looking for. So I'm going to say discrete 0 here, because that's the line that it's on. That's what I want to look. And I'm not going to check this manual. All that manual means is when I'm offline, if I send a manual event, will it capture it? And I could do this if I have some things that might be firing. I don't want it online yet and everything, so I'm just checking to see what the spreadsheet does offline. So I could do the manual, but if I do manual, I'll want to make sure I go back to A0 and deselect that. Otherwise, I'd be firing my event and an acquisition at the same time. That might not be what you want. So let me go ahead and say OK here. Just going to be discrete 0. Okay? And it has that event. So every time I push that button, it's going to capture that event. Beautiful. Now what do I do with it? Okay, it's capturing it. What do we do with that? Oh, that's great. Well, I want to count it. So underneath our clock data storage, there's going to be a function called count. So I'm going to go drag count, just put it next to the event. And the count is asking, what event do you want me to count? So what event is it looking at right now? Acquisition. So if all of a sudden I turn it online because I'm continuous and you see this number start going up, 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 you know you left it on A0. But that's not the event I want to capture. What's the event I want to capture? The button push. So I'm going to double click on event and go reference that event that I've just created. One of the things I love about these tools is they tend to, what they're looking for would be the name of what's sitting on your spreadsheet. So it kind of helps you find it. Now max value. Chances are I'm not pushing the button that long, so I'm fine with leaving the max value up at that very large number. Reset. Please don't leave this checked. If you leave this checked, you will never leave your preset value. And then preset is 0. Beautiful. Perfect. That's exactly what I want. So now, if I go, let me do one more thing. One more thing that I want to do is I actually want to read what that value is. Okay. So I'm going to go underneath my inputs and outputs again. Come on. There we go. Input and output. And I'm going to look underneath discrete. And there's going to be a read discrete here. Okay, drag and drop that over into here. So it says, okay, what event do I want to take a look at? What event am I reading right now? The button, right, exactly. This is being completely asynchronous, so it's not tied to the trigger. So I'm going to double click on my event, go back down, read the same button pushing event. And then I want to start at bit 0, because that's the one that my button's coming in at. And how many do I want to read? Just one. Just one. I'm going to say OK. Beautiful. So it puts me that little button there. OK. So now what I want to do is I want to start pushing the button. Uh-oh. Why isn't anything happening? Beautiful. I want to go online. Now before I go online, only because I've had those power issues, I'm saving it. So now let's go online. Notice it's acquiring. Nothing's happening. Now I hit my button. Now notice it's taking a little bit of time. That's because I have my continuous going on behind the scenes. If I switch my acquisition to manual, I see a much better reaction, because if it's in the middle of acquiring and processing the spreadsheet, it's not going to service the event till it's all done. But I'm double counting. Why am I double counting? Now you might say, well, I'll just do a rising edge or a falling edge. That's great, but you'll never see what the current status of that button push is. Because if it's a rising event, it'll always show it as high because it never knows when it drops. So you'll never see it go back to 0. And if I say only falling, then it'll always be 0 because you'll never see it rise. So that's why I did it on both. I know that it's doubled, but at least I know what my button is at any given time. I know what its status is. Okay? You guys can try it any way that you want. So that's my input. Let me just finish my output as well. So that got my input in there. Now what I want to do is I want to let it know that I have a good part or not. So where on my spreadsheet does it tell me that I have a good part? I don't have it yet, exactly. I have all these individual tools that are telling me whether they passed or failed. But I don't have anything that has told me that all my tools have passed or failed. So what I need to create is I need to create a global bit. So I'm going to go ahead and do a little comment called global bit. Let's accept that. Give it a little background. Come on. Now, what function could I use to check to make sure that all of my tools have passed? An AND. Perfect. So let me go ahead and go to mathematics. My logic. Let me grab my AND function. And what I'm going to do is I'm going to go choose my results here. So let me come up here. Oh, I'm not sure why I guess I was dragging on my spreadsheet without knowing it. So the first thing I want to grab is whether it was above my 85, my logic for my find patterns. Beautiful. I'm going to say comma here. And then I have this logic or my error controlled off my histogram. Which one do I want? The error controlled, exactly. Because if I did my logic, I could get a pound error. If I get a pound error there, nothing's getting sent out. So the next one, I do a comma, go down, choose my error control coming from my edge tool. Beautiful. Comma. And now I have all these blobs. Which one do I grab? The total. Yep. I want the total because that's already ANDed all the other ones. Beautiful. So now I can visually see, yep, those are the ones I want. Yep, yep. Let me go ahead and accept it. And so right now it's letting me know, indeed, it's the bad part. In fact, if I put this one underneath it, let me just, so now it's a good part. So now we have this bit telling us whether it's a good part or not. Beautiful. So now what we want to do is we want to write out. So write to I/O. So guess what function we're going to use to write to a discrete port? Write discrete. So let me go down to my input output discrete again, but this time I have my write discrete. Drag and drop that in. And my write discrete says what event's going to cause me to write out. So what event? It is acquisition. With every acquisition, it's going to give you what state your part is. So it's going to tell you every time, with every single acquisition, it's going to go and look at what's going on with that part. Now, where do I want to write it? Well, what output line do I want it on? We're probably going to, let's say output line 4. So we're going to write it on out 4. How many bits do we need? Just one, just saying whether it's good or bad. What value do we want to write out? That's the global bit. We want the result from the AND statement. So we reference that there. So now if it's a 0, it'll write a 0. If it's a 1, it'll write a 1. But it's being controlled by the acquisition now. So now let's go ahead and say, OK. What? Why does it say 0 there? But it's a 1. Why does it say 0? It's the online. It's not so much that it's quiet, but yeah, because it's an output. And that's one of the reasons I purposely changed it back to being good, so that you guys could see, don't get distraught here. It's not until I go online. As soon as I go online, now indeed, it's 1. In fact, if I take a look here, I can see my output. Now, when I look at my output 4, I'm not seeing it shimmy. Okay? I'm seeing it stay pretty solid. So what I need to do is I need to go in and need sensor discrete I/O settings. This time go to output. I go to line 4, and I'll just call this status bit so I know what it's being used as. It's programmed. But in my details, I want it to pulse 30 milliseconds works. Okay? I can't lower it more than less than 30 milliseconds because my RPI is 20. I can't go less than 10 above my RPI. It just won't let me do it. So I'm going to go ahead and say OK here. And now if I say OK here, if I now go on, if I take a look at 4, I can definitely see it going on, off, on, off, on, off. So now I know it's pulsing out there. If I stick my hand in front of it, I no longer see it anymore because it's failing now. Put it back in. Now for extra credit, I'd like you guys to change what those LEDs look like. I'll let you guys do that because now I want you to start getting comfortable that you can double click on things and not feel like you're going to break something. Okay, look around. It is pretty intuitive how to change this. And the other thing, for those of you who really want to push things, right to the LEDs on the camera. The user one and the red and the green LEDs on the camera.